I like putting pressure on it. But what I found is live code demos, you have to be so fast because you can lose the, like you can get it right, but you're context switching from your slides over to this thing, and then you have to start it up, and everybody's like watching you type code. And that's about as interesting as watching paint dry. And so I don't do that. But we can do, one of these days we'll do an ops manager demo, and it will be beautiful.
Switching is okay as long as the whole presentation is short.
Yes. Well said. That's not this presentation. This is going to be a long presentation. So, this is kind of a funny thing. Like I obviously like this photo, and I thought it was kind of cool. And go out on a limb. I thought people would laugh at me for making this kind of a thing on MongoDB Spark using this picture. But the funny thing that I found, and thank you for coming back. Thank you so much. You people have no taste. One thing is, like I get a lot in the field, MongoDB and Spark, not everybody knows these technologies, and there's some assumption that they're competing technologies in some way. Are they competing or complementary? And I like this photo because they're complementary technologies. They both handle data in a distributed system, but they work well together. In fact, when two data stores love each other very, very much, beautiful things happen. I don't know. Stale as toast. Okay, so let's talk about some level setting. How many people have heard of MongoDB? How many people have heard of Spark? Right? How many people feel really comfortable with Spark, like Spark Master? How many people would like to know more about Spark? Yeah, so one thing, the rule also is like, how many developers don't know about this technology? And everybody goes, you know, that's always never ask that question because no one's going to admit, yeah, I don't know that. Anyway, so these are interesting. This is actually an interesting piece of technology, Spark. I find that there's some people that are experts out there, but it's still the adoption on this and its popularity is very, very non-linear. It's just being taken up a lot. So there's people who know Spark really well. Sometimes I get in the audience. Some people who are just brand new and they're trying to learn. That's okay. This is a new technology, so nobody should feel uncomfortable about not knowing this kind of stuff. We're going to walk through and level set so that you guys are all on the same page. For those of you that know Spark and you know, just bear with me as we level set, and we'll make it through and you guys hang in there as we get everybody up to speed. Okay, Spark and MongoDB. Like I said, what's the difference between the two of these things? They're both distributed data systems, data management systems. Whereas MongoDB is a database, it has indexes, it's designed to do what's called fine-grained operations. You can perform operations on many documents, or you can perform mutations and operations on single documents, single records. Spark is about throughput, maximizing throughput, not necessarily latency. Maximizing throughput, not latency. So what does that mean? It means that it's doing batch processing. That's essentially what it boils down to. It's designed to maximize throughput because it's processing a lot of data, and it may be processing a lot of data quickly, but our expectations about the results that we get back from the processing that occurs on Spark is not real time. MongoDB is real time, right? And when I say real time, I say fractions of a second. In fact, you know, for trivia's sake, we consider anything as a rule that's over 100 milliseconds. That's recorded in the log by default as a slow operation. Operations in Spark, because we're processing maybe gigabytes, terabytes, petabytes of data. The operations, depending on what you're doing, could be several seconds, several minutes, several hours, right? Processing a lot of data. MongoDB is also, some people think that it's unstructured data. It's actually quite structured because there's fields and data types into a document structure. It's a flexible schema, but it's structured data. Spark is also used to process free text or unstructured data. It can process both, but part of it is to say I'm going to take news articles, I'm going to take articles that have appeared in blogs, I'm going to do sentiment analysis, for example. So different kind of thing. How does Spark compare with Hadoop? They do the same things. There's overlap in the tool sets, and in some cases you can think of Spark as a part of an extension or a sibling to the Hadoop ecosystem. There's a lot of moving parts in the Hadoop ecosystem. How many people are familiar with Hadoop, have used Hadoop before? Okay, yeah, and what is Hadoop? Well, it's a lot of things. It's a lot of tool sets. Will Spark replace Hadoop? Components of it, yes. Large swaths of it, yes. I do think that Spark is going to replace Hadoop. How many people have used Hadoop actually in systems? Gentleman over there. Yeah. So why is Spark replacing Hadoop? Why is Spark so buzzy? Actually, I usually ask people because Spark is pretty amazingly buzzy. But there was something before Spark that was even buzzier back when dinosaurs roamed the earth, and I was a younger programmer. And that was Hadoop. Like, everybody was into the Hadoops. I remember the president of the company I was working for was like, couldn't we just get more of the Hadoops to solve this problem? Like, Hadoop would solve everything, right? And I said, we could. And there's other ones like, oh yeah, you're the company with the Hapoop. And that's an easy joke, but that did really happen. You use the Hapoops. And I said, I hope not in front of everybody. So Hadoop came along, and it was a panacea. People thought that Hadoop would solve all of their problems. There was a white paper in Google Bigtable, and then Yahoo came out with Hadoop, and then the world was going to change. People were going to dance in the street. And so you got this kind of adoption phase where people were enthusiastic adopters. But it's a distributed system. It does specific things well, and other things not so well. So that enthusiasm kind of started cresting, where people were like, this is not working the way I think it would, or this is a complicated system where my a business analyst person doesn't know Java, he doesn't understand how to create these programs, these tasks, and it's taking longer than I thought. So it went from enthusiastic adopter to essentially the trough of disillusionment, which, interestingly enough, was the name of a punk band that I was in the 90s. I thought this would be. Folks. Okay, so Spark is, it's gaining a lot of buzz because it does the same things that Hadoop does, because it's learned from this decade of people using Hadoop. One of the things that are pretty compelling about it is that you can use an interactive shell mode and perform SQL-esque kind of like operations on Spark that you can't really do in Hadoop. It's easier to deal with. It has a fluent API that is easier to program with. It's not easy in itself. It's still a distributed system. It's written in Java and Scala. You got to know what you're doing with this kind of stuff to understand how to set up a cluster, how to run it. It's not impossible, but you have to have a level of competency that makes it a little bit easier to deal with. And probably the thing that it is most known for is these amazing performance numbers, because it's using a cache. It has a caching layer that vanilla Hadoop does not have. So where's the caching going to really be beneficial? If you're doing multi-pass algorithms. You're going over the data set multiple times to get the processing done that you need to do. An example of this is the algorithm that made Hadoop famous in its own right was the PageRank algorithm, the original PageRanking algorithm that Google used, named after Larry Page. And that's a multi-pass algorithm, right? You have to go over the data multiple times. If you're going over the data multiple times, a caching layer will improve the performance of the system. Otherwise, you're going back to disk, all the way down to storage to pull the data up, and this makes it prohibitively slow and high latency. So that's where all the buzz is coming from. So let's make sense of this ecosystem, these parts. Like I say, it's not easy. There's a soup of terms that compose the Hadoop ecosystem. So in order for you guys to go home and do your homework that we're going to assign tonight, and be back for the quiz tomorrow, I need to do some more explanation of how the system works. Now, actually, the thing with these talks is I want you guys to be able to at least know how to take a bite on this stuff. So what I want to do is talk about the ecosystem and the parts in it. Both Hadoop and Spark are, the way that they deal with processing huge amounts of data is to split a big problem into lots of smaller problems and solve them in parallel, right? You got a big sandwich you got to eat. Give portions of that sandwich to a bunch of people and have them eat it in parallel. That's off the top of my head. I'll think of a better analogy. Lots of little fish eating a bigger fish. So if we're going to do distributed processing, we need to distribute our data to multiple servers, right? So that the processing can occur in parallel across all of the servers. So in order to distribute this data across multiple servers, we need HDFS. That's the system for managing the distributed storage of the data across these servers. HDFS, who wants a gold point? Who's the first one who can say what it stands for?
Distributed file system.
Yes, circle gets the square, which is a reference to a 70s TV show. See, it was hilarious. So back home, they're laughing. So HDFS handles that data across all nodes. On top of that, whoops, there we go. On top of that, we have distributed resources. We're going to be performing processing. Our resources are RAM and CPU. And we need a way of managing those resources. So we have a layer on top of the distributed storage for handling the resources in a fair way. That is Yarn, which stands for? Too late?
No idea.
Yet another resource negotiator, right? So yet another resource negotiator. Why? Because it negotiates resources yet again. But that's basically what it's saying. I have CPU and I have memory. I know where the data is based on HDFS, and I can manage tasks, distributed tasks on these systems through that. What's new with Spark is Mesos. Some people call it Mesos, but they're wrong. It's Mesos, and this is a more generalized, newer, less specific implementation than Yarn is. Yarn is made for executing MapReduce, which is a strategy for processing data. Mesos said, like, MapReduce is great, but it's not the solve to every problem. If we're going to deal with distributed processing, we want to do it in a more generalized and flexible way. So Mesos can execute MapReduce, but it can do a lot more as well. And then, of course, when you guys go and test and play with this stuff, you'll be using the standalone mode, which is another way of managing these distributed resources. On top of this layer, so at the bottom, we have distributed data, we have distributed resources. The next layer is distributed processing, the strategy of processing this stuff. This is the Hadoop and Spark API. This is where we would say that this is actually synonymous right here at this level with MapReduce. We're going to execute a MapReduce task, a strategy for processing data. It's going to be executed on Yarn, on data that's stored in HDFS. Spark has a different API that allows you to do MapReduce, and yet so much more. So this is the way of issuing jobs and seeing that they're complete on the underlying layers. Okay? Again, Hadoop is very MapReduce specific. That's all it was written to do. Spark said, let's be a little bit more general about this. There'll be other processing frameworks, is what they call it, that you can execute on Spark, not just MapReduce. Outside of that, there's this layer of domain-specific languages. Part of the problem that people have with Hadoop, I've taught classes on Hadoop integration, and I made the mistake of starting off with like how the API works at the Java level. And there's a lot of people there that were data scientists, not that they're, well, they are. Are there any data scientists here? Okay, they're stupid. They don't know Java, right? I can't blame them, but I do. So they don't know Java, and I'm trying to show them how Hadoop works, and they're all like, what is that thing? What's that part of the code? That's a parameter. It goes into the function. That was one of the questions. I'm like, this is going to be a long day for all of us. So there's a lot of people who don't know those, even though it's a high-level language, they don't know Java, but they have domain expertise. They need to process the data. They're business analysts. They're data scientists. So there's a domain-specific languages like Pig, which uses a language creatively called Pig Latin, and then Hive, which uses HQL, which is a kind of derivative of SQL. And now we're into the realm of something that's a little bit more abstract and easier for the kids to use in their hip-hop music these days. So they can interface with the back-end system easier. Now there's a danger with these abstractions, that they're easy for you to write stuff that will bring down the performance of the system because they're abstracting how all of this stuff is executed. For instance, Hive and Pig get compiled into MapReduce jobs. But you can do all these joins in Hive, but they end up becoming multiple pass MapReduce tasks. you pass over again and again and again to aggregate all this data and present it to you. And then you wonder why it's taking forever for this stuff to complete. It's because you didn't know that what you were doing is creating these multi-pass systems. At that same level, Spark answers this problem by having their own version of Hive HQL called Spark SQL. It's the same language, but it makes benefit of the Spark caching and the Spark API underneath it. So, and you can also use it with the interactive shell that you can use things called data frames, and everybody's impressed at parties. And of course, there's this streaming component that there was a gentleman here that was asking about, like when I talked about Lambda architectures, the streaming component in Spark that allows you to update real-time systems while also sending updates to the database. So there's really some interesting stuff at this level. Just as a recap, the blue is vanilla Hadoop. It's worth knowing the difference between these two systems so you understand why one may be used in favor of another, or you can, Hadoop will be with us for some time. There's still a lot of expertise out there in using Hadoop, so it's worth to know. It's not going away now, soonish, but it's good to know how these systems work. Because again, you'll see here that Spark works with Yarn, right, and HDFS. If there's one kind of unifying component of the ecosystem, that's probably HDFS, because all of these systems are going to be talking to a distributed layer down low. On the right is the yellow stuff is the Spark stuff, okay? Where does MongoDB fit in this ecosystem? It fits at the center. Because what we want to do in this kind of integration is that we're going to, instead of drawing data off of HDFS, we want to draw it off the database that we're using to service our front-end applications, right? Now there's tricks there that you can use in MongoDB such that if you're doing these big, heavy analytics loads against the database, you can isolate that load away from the servers that are serving your front-end business, highly available business logic. But the idea here is that we can greatly simplify this whole kind of stack by using MongoDB at the center. What are the advantages? The advantages are that I've reduced the number of systems that I'm dealing with, right? If I'm going to have a database that supports my front-end business logic. But then I'm ETLing data off into an HDFS system that's parallel, so I'm getting data duplication. And then I connect my Spark system up to the HDFS system. Well, there's problems with that. Now I have two systems I need to maintain, two different domain expertise, the HDFS expert and the MongoDB expert, and these ETL systems, they sound trivial, but they break all the time, right? They need to be maintained. What happens if you're not ETLing off data, right, from the database? That was a major component of my work on distributed systems for online advertising and marketing, is we had to keep the logs flowing. Like that's what I got paged on, was when the logs stopped flowing from the business servers, right? And we would lose money when the logs would stop flowing. So if you can eliminate that complexity, you get more robust systems, simple to manage systems, and the time that it takes to get data off of the database, process it, and shove it back into the database is reduced so that you get what I would call faster time to analytics. So what we were doing is we were doing real-time bidding, and so I wanted to update my bidding models frequently based on who's appearing, what we learn about people, what, should I bid, how much, what's the going rate, what do I learn by analyzing these logs. With a normal ETL system into a back-end HDFS system in Hadoop, I would wait 24 hours to update, to get the processing done optimistically before I got my bidding models updated. In this system, I can do incremental analytics in a set of 10 minutes, right? The last 10 minutes, I process of new logs and I update my bidding models. So that excited me quite a bit. I ran around the office, people were, shut up, I'm too excited. But I was, it was cool. So yeah, that's how the ecosystem, this is not all the ecosystem, right, of course, but this is a good way of looking at it. Now even yet, this can be looking pretty kind of complex, and it's a kind of a system for predicting the future to some degree of veracity. And these systems work, in mysterious ways, but we're going to try and reduce the mystery of these systems. So let's dive into how Hadoop Spark actually does its magic. I'm going to eliminate the Hadoop stuff and just concentrate on the Spark stuff. And specifically, the easiest kind of use of Spark in MongoDB is just this layer, the basic API, the standalone mode in MongoDB. Okay, the way that Spark does its processing is that you have a master process that coordinates the individual jobs that are executed on worker nodes. And each worker node has a series of executors, right? And the master says, hey, guess what? I'm going to say, this guy is sending me a job. I'm going to initialize that job and make sure it gets completed by sending work to these executor nodes. You process this amount of data, you process this amount of data. Who gets what work is based on a couple of different things. It's based on how much CPU is being consumed or how much available CPU. So if this guy gets saturated, I'm not going to keep sending him more work to do. I'll send it over to this guy. How much RAM I have available. If I'm exhausting RAM, I'll try and distribute the work a little bit more evenly. And then it'll also say, if I've got an HDFS node is on the same server as an executor node, and the data that I'm looking to process is on this node, I want to assign work to an executor where the data lives, so I don't have to move bits over the wire. Okay. So how much CPU you have, how much RAM you have, where is the data? If this executor is co-located where the data is, process it right there. If that executor fails, I'll have somebody else process it, but I'm going to have to move bits around the wire. That's okay because I still get my job done. To use Spark with MongoDB, you use a driver. You have what would be called a driver application. You use our Hadoop connector, which is also a Hadoop Spark connector, and it's because we're written in Java. The Hadoop and Spark is written in Java. We're going to use our Java driver, of which I used to be an engineer. It's a great driver. It's fantastic. Brilliant people used to work on it. And then I submit my jobs through there. Now, when I submit a job there, how many people are tired of being asked how many people? How many people have used the aggregation framework in MongoDB? Okay. Yeah. Yay. Good. Good. I would expect that. I myself have not. Yeah. I myself have not. So I've just exposed myself as a fraud. Now, the aggregation framework is the basic idea of the aggregation framework is that when you create an aggregation task, you're going to process some data on MongoDB by stringing together a series of operations that are executed in a pipeline fashion, like the Linux pipe, piping commands in Linux. How many people have done that? Yeah, same idea. Okay, the reason I talk about that is I wanted to say we're going to take a look at the way that Spark, we're going to use fancy words to describe what Spark does, but it's very similar to the aggregation framework, which is very similar to Linux piping. The output of one job gets piped to the input of the next job, gets piped to the input of the next job, and we get something in composite done by a series of pipeline operations. What's going on here is Spark uses what's called an RDD, a resilient distributed data set. Let me do a quick time check. We have forever. You guys comfy?
8 minutes.
8 minutes. You guys comfy? You should be, because there will be a quiz. Okay, so what we're going to do is we're going to build an RDD, which is like a pipeline of processing. The first part is to parallelize it. How many people can say parallelize? That always trips me up, and I'm so happy when I say it. 1, 2, 3.
Parallelize.
Very good. You're now a Spark expert. More beers and you won't be able to say it. Parallelization means that we're going to create a data set that's a data set in parallel on these systems. Parallelize, boom, energize. And then the data is ready to, the RDD has begun. And it starts. We parallelize it. It's usually we're drawing data off of MongoDB or HDFS. MongoDB is much better. We can parallelize data that we've created and add data to it, like we have some function that we're creating a starting value, and then we're going to add data to it from the underlying system. But usually you're drawing data up from MongoDB. Next, we're going to issue transformations on the data. We're going to pivot, project, we're going to add in data, we're going to change the data from one state to another state. RDDs support two kinds of functions, transformations and actions. Transformation transforms the data. T of x goes into t prime, x prime, x double prime. This series of transformations. Whoops. And some of these transformations, what's nice about it is that they have function names that are really easy. We have a filter function to say like, well, I don't want all of the data, I just want this amount of data that's talking about how great Brian is. I want all the articles on how great Brian is, all one of them. And then we're going to do unions, we're going to do intersections. You know, it's very easy to understand what's going on. Distinct. You'll notice that there's we pass in functions to these guys, right? It's actually Spark is written in Scala. It also has a Java API, and we're going to either be passing anonymous functions into the system to do our processing, or we're going to use basically the functional notation of Scala, right? So there's a lot of flexibility that we can do here. After that, we can perform an action. An action returns a result. Transformations transform the data, but the action returns a result. An action would be something like collect. I mean, give me all the records that I've filtered on and transformed, now collect it, bring it all to me, and that's my result set. Count would be another one, right? The parallelization of the data stops when you have to start doing this grouping and counting, right? Because you're saying like, count all the records that I've found on my system. Or take the first record, that's all I care about, or the first n amount of records. Now you'll notice there was a mapping function and there's a reducing function here. This is how Spark accomplishes MapReduce as well. How many people know what MapReduce is? Okay, that's a fair amount. I'll just do the nickel tour. MapReduce says I have an input data set. I'm going to map it into a transient state, intermediary state that's easy for my reducers to reduce down to an individual result set, right? Or reduce it to get the answer I'm looking for. So map into intermediary step, and then reduce, 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 reduce. Say that, and everybody will think that you're a genius, because you guys think I'm a genius. Okay, so those are the actions. The total amount of everything, in the aggregation framework, we call this pipeline. In Spark, they have to be different. These kids, they call it the lineage, the RDD's lineage, right? The resilient distributed data set's lineage is the sum of all of these operations. Why do we care that there's a lineage? Because when we think about these as stages, the lineage has stages of processing, and we're going to have these executed. The data flows through the lineage and is executed in parallel across these servers. Knowing the lineage is important because if we have a failure on the system, boom, right? A partition is lost for some reason. Not all of the data processing has to be regenerated. We can just replay the lineage, that word again. We can replay the lineage to make up for the loss of that partition. We don't have to start from scratch. We just go back and replay the lineage or a portion of the lineage that we lost. Right? And we can carry on with our lives, which is more than I can say about you people being stuck in this room. Okay, so how do I use this magic? Well, we have the Hadoop connector. It's an open source project that you can contribute to today. You can download it here. It's in GitHub. A good friend of mine, Luke Lovett, is the current maintainer. And basically, it's the same connector that you would use to connect to a Hadoop cluster you can use with Spark, because the two are related. You know, they have a common DNA. So you download the Hadoop connector. There's examples in the examples directory that I've written for that you can use to try out the Spark connector itself and impress your friends. The way that you use this, there's two basic things that the Spark connector, the Hadoop connector needs to know that Spark needs to know to get its data from MongoDB, either to get it in or out of MongoDB, because you can write back to MongoDB results. The two things that we're going to do here in this case is we're going to read from MongoDB. So number one is we need to know where the server is, give you the URI. Spark needs to know who to talk to get the data. Once it's made this connection, it needs the second piece of information. How do I interpret it? How do I use an input format to say, okay, great, here's the source of the data, but how do I get the data off the server? How do I get input splits and stuff like that? That's this part, the input format. You pass this into a configuration object, and then you say, okay, great, Spark context, the gateway into processing. The configuration tells the Spark context what to do. The context is the way into processing on Spark. You pass in the configuration to the context. You give it some more parameters. Here is basically the input format class. Again, the Hadoop API system needs to know that information about how to read from the system as well. So there's a little bit of duplication there. But we say like, hey, we're going to, what we're getting out is a BSON object, right? Because that's what's in MongoDB is binary serialization of JSON objects. A BSON object, that's the value I get back, the unit of data that I want to get back. And I'm going to be getting a stream of Java pair key value pairs. The key is the object class, like the shard key would be one of them, the key that is your shard key, or the underscore ID. I'm getting a stream of BSON objects in the form of a key value pair, right? That's what I get back, key values. And then I can perform my that has parallelized the RDD on the Spark processor nodes, and from there on I can apply more transformations. I can do an action. I can just drop it if I feel like I just want to, just let it go out of scope and be exhaust memory on my server for no apparent reason. But that's basically it. And then submitting a job is really easy. You use the binary Spark submit. You say this is the class of the main class where the main method is, and this is the jar that contains all the goodies, right? The Hadoop connector jar, the Java driver jar. And you're off to the races. You're using Spark, and people will laud your efforts. There's no easy way to make code look simple on slides, but folks, it is that simple. It's just that simple. Okay, so other parts of the Spark ecosystem. The Spark shell, the interactive shell, is fantastic. It's a joy to use. Tears came to my eyes. Flowers bloomed, clouds parted, birds flew. And we're going to use Spark SQL. So another way of working with Spark is that same notion of these domain-specific languages. Maybe I don't want to work in Scala. Maybe I don't want to work in Java. So there's a special type of RDD called a data frame. And a data frame is just an RDD who knows somebody. It has a little bit higher status. And so the RDD is given, you tell it that it has a schema. Like there's columns and they have a name and type. And now it becomes an in-memory distributed analog to a table, like a relational table, that you can use SQL commands against. This is great for data discovery. This is great for analytics, where you're just kind of playing around, you're discovering what's going on with the data, doing just kind of looking at the data, and you can even fire off real analytics on it through the shell, right? The way that you assign a schema to an RDD, you say that it's going to have these tables. There's two clever ways that Spark does this. The first way is you say, hey, the data that I'm getting back from MongoDB has these field names and these data types. You declare what you say programmatically what the structure is. Or Spark can discover it with reflection, right? You give it a bean, the message class. So in this case, I'm processing the Enron emails. These were a series of emails that after the FCC investigation to that bankrupt power company, they made public the emails in the investigation, so it's kind of fun to see who's talking to who. And so to process this in Spark to find out what they're talking about and do all sorts of interesting analytics on it, what I'm going to do is create an RDD of messages, right? I'm going to make a table of messages, to, from, and text, or header and body. So I've created a message object in Java. It's a bean. It has getters and setters. I give it to the RDD. It's going to map this into a data frame, and it uses reflection in the class to derive what the column name should be. Very, very cool. If you know what the structure is, this is a very succinct way of creating a data frame. If you don't know and you want to play with the data programmatically, that's the declarative programmatic interface. Am I making sense here? Any questions so far on this? No questions?
C#, is it just Java?
It's just Java. It's actually, you can use C#. You can't use C#. What am I saying? Power of suggestion and jet lag. You can use Scala, Java, Python. You use Python and something else. There's a fourth language. I can't think of it right now. But those are the heavy hitters. Those are the best, the greatest hits of languages in Spark. The boyzone of, the menudo of, there's the cute one. Okay, so to look at another way of using the Spark shell with the data frame, this is actually a cool data set I found from NASA. It's the logs of all the extra vehicle activity spacewalks that occurred both in the Russian space system and the American space program. So anytime an astronaut left the capsule or the space shuttle or the ISS, they recorded this log. And I thought, oh, that's kind of cool, let's play with this. This is what it looks like in MongoDB. Just a document, very simple, kind of flat, right? There's the log of what happened. So what I do is, this is what it looks like in the Spark shell, me playing with it. I've translated it into a data frame, right? I'm using Scala. And the story is that there's no story here. It looks like a table, right? No big deal. That's the point. No big deal. It's easy to use. Yay. And so I said, like, show the first 20. And we see that the first American in space was Ed White. The first man in space to spacewalk was some Russian dude. But we're not jealous about that. Anyways, and then there's the table displayed. Over here I can say print the schema, right? Print the field names, and then there it prints out. It's just that easy. And that's, and my slide crapped out. There we go. So where are we going with this stuff? You noticed I talked that there's an existing Hadoop connector, and we use it to connect to the system with Spark. I just met with the developer who's working on a dedicated Spark connector that's written native in Scala. And that's coming down the pipe imminently. So the Spark connector is going to be Spark specific, right? You can use the Hadoop API to talk to Spark, but we wanted to do something that was a little bit better than that. So it's going to be it's written in native Scala, which is a very nice language, works really well with the rest of Spark. And of course, there's a Java API, because these are JVM languages. They're closely related, so you can mix and match and impress your friends. In addition to that, a nice feature that's going to be really interesting to see how you folks use it is you can pre-filter the stuff that comes out of MongoDB with an aggregation command. You could issue queries to the Hadoop connector to say, I don't want all of the data coming from MongoDB into Spark. I only want a subset of the data. But with the aggregation filter, you can do matching operations like the query would, but you can pre-aggregate data, you can pre-process data in MongoDB even before it comes into Spark. It's like a pre-RDD, or the RDD is a post-pipeline, whichever perspective that you like. But I'm excited about this. This is really a cool little trick. In addition to that, we will have data locality, which means that if you have a Spark executor co-located with a MongoDB on the server, it will assign work to the Spark executor on the server so that you're not moving bits over the wire. Right? The Hadoop connector, the way that it works is that it's a client of MongoDB. So you're taking data out of the system and processing it in a set of executors. Is this better? Well, you eliminate network hops, which is great, but you got to be careful. The consulting engineer in me says you got to be careful, because these systems will compete for one another for resources. So if you're going to co-locate nodes like this, you need to be careful that you have the proper hardware allocation based on the processing that you're doing, right? You can't pack everybody into a Yugo. You can't put 50 people in a Yugo and expect to drive safely. Yugos were cars then from the 90s. I am like a car from the 90s, totally worn out and useless. But charming. Not really. Anyways, you know what I'm saying here. It's cool that you eliminate a network hop, but you need to be careful about your hardware allocation, right? You don't want to shoot yourself in the foot. But this is going to be an interesting thing to have here as well. That is the long and short of it. And thank you so much for that.